All right, today we are going to finish up our last lecture for this unit, which is essentially flow of matter and energy through the Earth. This is really just the last part before our test next Friday, okay? So we're still going to continue this on after we come back from break, but I'd like to wrap it all up with a mini test right before we go on break so that you don't have to worry about memorizing all of the stuff and then keeping it until the next time. All right? So ecosystems in the biosphere. So an ecosystem is all the living organisms in a given area, as well as the abiotic factors with which they interact. So, as a quick overview, all of the organisms living on Earth need energy to carry out life processes such as growth, movement, and reproduction, right? Without energy, we can't do anything. And where does all the energy in the entire planet come from?
Sun.
Yes, the sun. In an ecosystem, the ultimate source of energy is the?
Sun.
Yay. Sun. So energy flow through an ecosystem. This is really what we're going to focus on for this lecture. And this will be on next Friday's test. So sunlight is the main energy source for all of life on Earth. Have to have the sun. Sun's gone, we're gone, right? Without energy from the sun, life could not exist on Earth at all. Of all the sun's energy that reaches the Earth, less than 1% is actually used by living organisms. That's not very much, right? Additionally, this 1% is used by organisms that are capable of photosynthesis, right? Photosynthesis is the process of capturing light energy and using it to make glucose and oxygen. So green plants and a few other organisms use the light energy from the sun to convert water and carbon dioxide into glucose and oxygen, which is essentially what I just said, right? Okay, so the organisms on Earth that carry out photosynthesis rely on the energy that has been stored in the organic compound glucose, a type of sugar, right? We kind of beat this to death, hopefully, last unit. They make the glucose. We as heterotrophs eat the glucose, breathe the oxygen, and we turn it back into carbon dioxide and water, which the plants take, turn it back into glucose. This sounds familiar? I hope. So not only does photosynthesis provide food in the form of sugars and starches, i.e. glucose, okay, for many of the organisms on Earth, but it also removes carbon dioxide from the atmosphere and releases oxygen, which is really important, right? Can we live on a planet full of carbon dioxide? No. We would all slowly go to sleep and not wake up. Yep. All right, autotrophs. Do we know what autotrophs are?
Yes.
Very good. They make their own food. So autotrophs are organisms that have the ability to use energy from the sun to convert inorganic substances into, you know what? If you don't want to type that whole thing, you can just say autotrophs make their, exactly, make their own food. And then I'm going to draw, this is my piece of pizza. That's an awful piece of pizza. It's so autotrophs convert carbon dioxide and water into glucose. Don't forget that you can always abbreviate carbon dioxide as CO2 and water is?
H2O.
Excellent. So on land, the green plants are the main autotrophs. In aquatic ecosystems, algae are the main autotrophs, okay, right? There's not there are kelp forests under the ocean, but really what's releasing lots of oxygen into the ocean waters is the algae. So photosynthetic bacteria, or what we call cyanobacteria, are also important oxygen producers. So we call our autotrophs producers. When we're talking about energy and ecology, we call them producers because they're the ones that are producing the food for everyone else. They are essential to the flow of, what do you think it is?
Life.
The flow of life.
Energy.
Thank you. Energy through the ecosystem. Whoops, sorry. So our life is extremely dependent on autotrophs, right? If there's no autotrophs, there's no food for all of the heterotrophs. So that's not good. And without them, we would not have food to eat or oxygen to breathe. Oxygen you can also abbreviate as just, as O2. Oxygen gas is actually O2. When you guys take chemistry next year, you'll be learning all sorts of fun stuff like that. Heterotrophs, okay? Many organisms cannot directly use the energy from the sun, correct? Can we go outside and just use the sun's energy? No. That would be cool. But I do love donuts, so I don't know how I feel about them. These organisms acquire their energy from what? Love it. Other organisms. Eating other organisms. So heterotrophs are organisms that don't make their own food. You can just write heterotrophs are organisms that cannot make their own food. That's plenty. That obviously implies that they rely on other organisms for their energy and food supply, so you don't have to write that if you don't want to. Heterotrophs are also called, and this is really important, you might want to highlight it in your notes. When we're talking in terms of ecology and energy flow, we call them consumers because they consume the producers, right? They consume other organisms. So there are many types of heterotrophs. The three we will talk about right now are herbivores, which obtain energy by eating only plants. Carnivores, which obtain their energy by eating other animals, specifically, right? They consume other consumers. And omnivores eat what?
Plants and meat.
Perfect, both. Isn't that bear cute? Detritivores. Any guesses on what they do? They feed on what?
Bacteria.
Excellent. Dead things. Plants. Animal remains. Animal wastes. Yes, animal wastes. Yeah. And other dead matter. So obviously some examples of this would be...
A vulture.
Good. A vulture. Mites. Like dust mites and stuff, they eat dead skin. Okay? Earthworms, snails, and crabs, actually, are detritivores. That's why some people say that some people love crab as like seafood, and other people like gross. It's an animal that eats dead. It's like eating a vulture for Thanksgiving. Decomposers are a specific type of detritivore. All right. So decomposers they cause decay by breaking down organic compounds even further than the normal detritivores. Okay? Decomposers include bacteria and fungi that look like this under a microscope, or you can see mushrooms. Okay? And some of the molecules released during decay are consumed by the decomposer. And some of these molecules are returned to the soil or water. This is what really actually starts breaking things down at a molecular level and putting nitrogen back into the dirt, putting phosphorus back into the soil. Okay? So these take decomposition and take it another step further. The action of decomposers makes the nutrients contained in the dead bodies and wastes of the organisms available to autotrophs. In other words, this is really what causes the circle of life, right? So obviously you have carbon in your body and nitrogen in your body, calcium, phosphorus, and it's not until the decomposers do their job that those become free elements that the plants can use or that can be harvested out of the ground, things like that. So the process of decomposition is to recycle chemical nutrients. And this is what we'll be talking about when we come back from break. Come back from break, we're going to talk about carbon cycle, nitrogen cycle, phosphorus cycle, and water cycle, the biogeochemical cycles. And obviously all of these cycles happen because of autotrophs, heterotrophs, and detritivores. So what would happen if there is no decomposition in the planet? What do you guys think would happen? Yes, sir. Everything would die. Why?
There's no circle of life.
There's no circle of life. Excellent. And if there's no decomposition, every single person, animal, everything that's ever lived would have a dead body laying around the surface of the earth. Do you think that would take up some room? Yes. All right. So all life on Earth would cease as detritus, or dead organic matter, piled up, and the supply of chemical elements needed to build new organisms would be exhausted. So after so many generations, there would be no more carbon to build people. There would be no more nitrogen for the plants to use to make photosynthesis happen. That kind of stuff, okay? So quite literally, it ends the circle of life. Chemical elements such as carbon, nitrogen, and phosphorus must be recycled to be used again in new organisms. And that's true of water also. We have a finite amount of water on the planet. So that has to be recycled. When you die, eventually your body releases all sorts of lovely, stinky liquids that go into the earth, and part of that is water. And that water gets pushed into the oceans, it might get evaporated and then rain over on the mountains, and then you might drink it eventually. Yes, this is truly the water cycle. In summary, energy enters the ecosystem in the form of sunlight. It is converted to chemical energy by anyone? Sun. Good. The sun is turned into chemical energy by the autotrophs and passed to the heterotrophs, which are the cows. Look at that. Isn't that a cute cow? I think so. In the form of organic compounds, molecules of glucose. Right? Our whole last unit was just focusing on this process. Sun to the plants to the animal wastes go back to the plants, and we do it all over again. All right, feeding relationships. What happens to energy in an ecosystem as one organism eats another? Right? When you have steak, or when this cheetah hunts down that gazelle. The energy flows in a one-way path through the ecosystem. Energy enters the ecosystem in the form of sunlight. Photosynthetic organisms convert the sun's energy into molecules of?
Glucose.
Yes. And then this energy is passed on to the animals that eat the plants and to the animals that eat other animals. Do you feel like I'm driving this point home?
Yes.
We understand this concept? Excellent. I'm not really going to repeat this one more time. You don't even have to write it down. We got this point. Yes. Hold on. Excellent. So, food chains. The energy stored by producers in the form of glucose molecules can be passed through an ecosystem along a food chain. We're going to look at food chains and trophic levels and stuff like that to conclude this little unit. A food chain is a series of steps in which organisms transfer energy from one organism to the next by eating it or by being eaten. Okay? So when you have your chicken nuggets, you are a part of a food chain. You ate the chicken that ate the corn. The corn got its energy from the sun. Excellent. And there you go. All right? All food chains begin with what? An autotroph. It has to start with a plant, right? Because plants are the only thing that can get energy from the... Love it. Examples of food chain. So the grass is eaten by the mouse is eaten by the snake is eaten by the hawk. You always draw the arrow towards what's eating it. Another one, marine algae to the zooplankton, to the small minnow, to the squid, to the whale. Is there anything else on this? No, I go back. It's okay if you don't get it all down.
Oh no.
All right, it's okay. A simple food web. A food web is just like a bigger picture of a food chain. It just shows all the relationships. So in an ecosystem, the feeding relationships between organisms are much too complex to be shown in a simple food chain. So instead, we use a food web. Because do we only eat chickens? No. Most consumers eat more than one type of food, right? We eat chicken, we eat beef, we eat pork. You might eat lamb. I love lamb shawarma. Oh my God, so good. You might eat fish. You might eat a salad, which is a producer, right? So more than one species may feed on the same organism. So there are many complex interactions between different food chains. All right, food web. Hold on, we might skip this slide. Let's skip that. Let's go to trophic levels. Okay, trophic levels. So each step in a food chain is called a trophic level. And this indicates the organism's position in the sequence of energy transfers. So the first trophic level is always made up of the producers, right? Because they're the only thing that can harness the sun's energy. So that's always at the bottom of the pyramid. These organisms are referred to as primary producers. The second level is occupied by the herbivores. Okay, so if you're a vegetarian, you're kind of down on that herbivore level, especially if you're vegan. You're on the herbivore level. Okay, things that only eat plants, like chickens, Well, I think chickens eat worms too, so that was a bad example. We're going to say that rabbit only eats grass. Okay, yes, cows only eat grass. Very good. So the second trophic level is occupied by herbivores herbivores that feed on the producers. There we go, that feed on the producers. So we call this level, so these were the primary producers, right? We call these next level the primary consumer. Okay, so you denote primary with a 1 and a circle. So this would be like a 1 degree consumer. And this would be a 1 degree producer. Does that make sense? What do you think the next level of consumer is called?
Primary carnivore.
No.
Primary carnivore.
What comes after a primary?
Secondary.
Herbivore.
Secondary consumer. The last one?
Top. Primary.
Good. Tertiary consumer. Okay. So, predators of herbivores belong on the third level, and these organisms are referred to as secondary consumers. They eat the primary consumers and possibly the producers. Each consumer depends on the trophic level below it for energy, right? The snake eats the mouse eats the grass gets energy from the sun. So each thing is dependent on the thing below it. Most ecosystems only contain 3 or 4 trophic levels. And I'll tell you why. Do you think when you eat a salad, you get 100% of that plant's energy transferred to you? No. Okay? So since some energy is lost at each one of these levels, right? If you go too high, you're essentially getting absolutely no energy from your food. There's just nothing left to give. So productivity of the ecosystem. Let me see. We're not going to talk about gross primary productivity. So don't worry about that. Let's skip down. We're not going to worry about this. Try and shorten this for you. All right. Biomass. So see if you can scroll down. Hold on one second. Okay, so energy transfer between trophic levels. The amount of energy or matter in an ecosystem can be represented by an ecological pyramid. This is the last bit of stuff I really wanted to get through because you'll need it for your packet, okay, for next week. The ecological pyramid is a diagram that shows the relative amounts of energy or matter contained within each trophic level in a food chain or web. Trying to see. Let's see. This is really what I want you to know. Ecological pyramid, it shows the relative amounts of energy or matter contained within each trophic level. You know, hold on a second. I think this is going to be our last slide for today, all right? Maybe 2 more. Roughly 10% of the energy consumed in one trophic level is passed to the organisms in the next trophic level. All right, so that's why we have this pyramid shape. All the energy is at the bottom, and you lose some each step you go up, right? Whoop, sorry. All I'm really worried about you having down is this box. That's the most important thing. So why, this will be our last slide. This is the one I wanted. Why is the transfer of energy to the next trophic level so low? All right. Not all the energy possessed by the organisms at one trophic level will be passed up to the next. So organisms use as much energy as they consume for their own life processes also, right? So the plant's getting all the energy from the sun, but the plant has to use some of that solar energy to just be a plant and keep being a plant. Okay? Then it can feed the other 10% to the next level. Many organisms at one trophic level will escape being eaten by the predators at the next level. And the energy of these escapees will not be passed to the organisms at the higher level. And once you have finished this, then you can go ahead and finish the notes for today. This is as far as we'll go. And I will pass out your packets to you. I highly encourage that you try and at least finish the first page over the weekend. If you would like extra study time and review time during class, that would give us time to do like a Kahoot or something like that, which I think would be really beneficial to you guys. All right? So that's a wrap.